Hi everyone, this is your teacher Ronald Henry Chivina, your physics and math teacher. I'm continuing my series of O-level physics with pressure. Please don't forget to subscribe to our channel, Tower Academic. Subscribe and get more videos. So pressure is basically force acting normally per unit what? Per unit area. So pressure is equal to the force per unit what? Per unit area. Now, to derive the S signs of pressure, we know that force is measured in newtons, and then area is measured in meters squared. So what does that mean? It means that now our pressure will be measured in newtons per meter squared. But fundamentally, 1 newton per meter squared is equal to 1 Pascal. So what does that mean? That generally, the S sign of pressure is Pascal. Remember, Pascal is the name of a person, so the symbol is capital letter, but the name is small letter. Let us have a small example. For example, if they told you to calculate the pressure exerted by a body of mass maybe 50 kilograms with an area of 20 meters squared. So if the mass is equal to 50 kilograms, what force does the body exert? The body exerts a force which is what? The weight. So the weight here, which is our force, will be equal to mass times gravity, which will be the same as the mass is 50. We know that our gravity is 10. So times 10, giving us 500 what? Newtons. We have said that the area is equal to 15, let us say 15 meters squared. Any area you have. So from our definition of pressure is equal to force over area. So our pressure will be equal to, what is our force? 500 newtons. What is our area? Area is 50 meters squared. We shall cancel this and we shall have this is equal to 10 newtons per meter squared. As simple as that. So whatever area you give it, whether area is 25, whether area is 30, it's what you put down here. But for this case, I will assume that my weight is 500 newtons. My area is what? Area is 50 what? Meters squared. Now let us look at the concept of minimum and maximum pressure. For example, if I gave you two cases here, one with a sharp needle or sharp point, one with a blunt point. If I exerted this one in my hand like this, and exerted this, in my experience, or even if you do it yourself at home, you realize that you won't feel much more pain with this sharp pointed one than this blunt one. What does that now mean? In conclusion, we mean that the smaller the area, the higher the pressure. The larger the area, the lower the pressure. So this one brings up a concept of minimum and maximum pressure. So it means that for the pressure to be minimum, as I've told you, you'll have, it should be the same as the force over the area should be what? Maximum. When you have a larger area, you experience less pressure. When you have a smaller area, you experience more pressure. Implying that for your pressure to be maximum, you have your force over the area should be what? Minimum. When you look at the comparisons, it means that if our if our force is constant, then the pressure is inverse proportion to the area. Implying when the area reduces, the pressure increases. When the area increases, the pressure does what? Reduces. And this has got a number of applications. There are so many applications for this principle. For example, you'll be surprised. Why is it that it is easier to drive a tractor through a muddy ground which is very heavy with big tires compared to a bicycle? When you go riding a small bicycle in a muddy ground, it's very hard. Why is it that for the bigger and heavy tractor, you can go through? Simple. The tractor has got large tires. And because of the large tires, the area becomes what? Maximum. And because of that, the pressure becomes what? Minimum. So because of the larger tires, a smaller pressure is exerted on the what? On the grounds. Or the software. Therefore, for example, to what? To move through. When look at the bicycle, it has got very small tires. And because of the small tires, it exerts maximum what? Pressure. Therefore, forcing into what? Into the ground. Similarly, when you wear your shoes, the high-heeled shoes will damage the floor compared to the large shoes. The larger the shoes, the smaller the pressure exerted. Whereas the smaller the shoes, those high shoes, they exert too much pressure on the what? On the ground. And therefore they affect the what? They affect the ground or the surface of the floor. Thank you so much for this time. Next, in our next series, we shall look at the pressure in what? In liquids. Please don't forget to hit that button of subscribe on our YouTube channel, Tower Academics. Thank you so much. Meet again next time.